Assalamualaikum warahmatullahi wabarakatuh. We are from AS1 to 02H. Today we're going to present our video assignment for subject Math 183, which entitled Application of Differentiation, Related Rates. Our group consists of 4 members, which is me, Nur Aisyah Nadira binti Muhammad Fazil, Andriana Ainul Hayat binti Omar, Nur Sabrina binti Rosli, and Nuri Najwa binti Zulkifli.
I'll start with the introduction of differentiation. Differentiation is the process of finding the derivative or rate of change of a function. Differentiation can be carried out by purely algebraic manipulations. 3 basic derivatives and the knowledge of how to manipulate functions. So the 3 basic derivatives of differentiation are for algebraic functions, for trigonometric functions, and for exponential functions. And the basic rule of differentiation are chain rule.
Related rates problem involve 2 or more variables that change at the same time, possibly at different rates. If we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing. This usually involves writing an equation relating the 2 variables and taking the derivative of the equation with respect to time. Implicit differentiation is often used.
So the objective of related rate is number 1, to determine the rate of change of one quantity as the rate of change of other quantities are known. Number 2, to find the rate of change of 2 or more related variables that are changing with respect to time. And number 3 is to use knowledge of derivatives to solve related rates problem. There are 5 steps in solving related problem, which is number 1, draw or sketch a diagram. Number 2, write down known information and what you are looking for. Number 3, write an equation that related to the quantity. Number 4, use the chain rules or implicit to differentiate both sides of the equation with respect to time. Number 5, substitute given constant values of function and rate of change to solve for your rate to be found.
Question 1. Let V be the volume of cylinder having height h and radius r, and assume that h and r vary with time. First, how are dv over dt, dr over dt, and dh over dt related? And second, at a certain instant, the height is 6 cm and increasing at 2 cm per second, while the radius is 10 cm and decreasing at 2 cm per second. How fast is the volume changing at that time? Is the volume increasing or decreasing at that instant? To answer the first question, first we have to write down the volume of cylinder, which is V equals to pi r square h, and then differentiate dr over dt, which is given by 2 pi r h, and dh over dt equals to pi r square. And lastly, we can just relate all those quantity, which is given by dv over dt equals to 2 pi r h dr over dt plus pi r square dh over dt.
So for question 1 number 2, by following the step, firstly, we need to draw a cylinder shape, as this shape has been told in problem statement. And secondly, we need to write down the known information and what we are looking for. So the question said that the height is 6 cm and increasing at 2 cm per second, while the radius is 10 cm and decreasing at 2 cm per second. Hence, the increasing show that the value of dv over dt is positive, while the value for dr over dt is negative. And next, how fast is the volume changing at that time? Is the volume increasing or decreasing at that instant? So, we are looking for dv over dt. So, thirdly, write the equation that relates the quantity, which refer to the answer in question 1. Fourthly, use the chain rules or implicit to differentiate both sides of the equation with respect to time. But this step has been applied in the question 1 already. So, we just need to apply the last step, which is substitute given constant values of function and rate of change. Therefore, we substitute the values of radius, which is Then, the value of height, which is 6, the value of dh over dt, which is 2, and the value of dr over dt, which is negative 2. Lastly, we will get the answer negative 40 pi, and the negative symbol shows that the value is decreasing.
So now let's proceed for the second question. A conical water tank has a radius of 3 cm at the top and 50 cm height as shown below. Water flows into the tank at a rate 6 cm cubed per second.
So for the part A of the question asks to show that the volume of the water is given by volume equal to pi h cubed over 75. So for the first step, we need to take out all the information that have been given in the question, which is r equal to 3 cm, height equal to 15 cm, dv over dt equal to 6 cm cubed per second. For the second step, we need to rearrange all the information so that we can find out the value of r. And then the last step, we need to just simply substitute r in the formula of volume count, and the last one you get the answer volume equal to pi h cubed over 75.
So the second question is, how fast is the height changing at an instant when the height of the water is 5 cm? So firstly, we need to write down all the information given. So from the question, we know that we want to find the dh over dt. When the height of the water is 5 cm. And from the first question, we know that the dv over dt is given by 6 cm cubed, and the volume is given by pi h cubed over 75. And then in order to find the dh over dt, we have to multiply dh over dv with dv over dt. And since we don't have any dh over dv in the question, we can differentiate the volume, which is given by pi h cubed over 75, to find the dv over dh. So dv over dh is equals to 3 pi h square over 75. And then secondly, we have to substitute all the information that we got. So dh over dt is equals to 1 over 3 pi h square over 75 times 6. And then we will get 6 over 3 pi h square over 75. Then thirdly, we have to find the value when the height of the water is 5 cm. So we have to substitute the h with 5. So we will get 6 over 3 pi 5 times 5 square over 75. And then we will get 6 over 75 pi over 75. So we can cut the 75, and the final answer would be 6 over pi.
For conclusion, all the objectives that have been stated before are accepted. By using related rates, we can find the rates of change of two or more related variables that are changing with respect to time. And we also can solve the problem that related to this chapter. And this is a few references that we refer to.